All right, so AP Calculus, this is a volume of solids of revolution question. And big shout out to Mr. Rod Houk from Leboldus High School, who gave me some help on this. So nice work. This is actually a tougher question than I had thought it was going to be. A revolution around the x-axis for this one, pretty straightforward. But I wanted to up it a little bit for you guys and revolve it around the y-axis. Now, the issue with this one is that if you take this, and here's the, these are the boundaries here, right? They're here, and here's the x equals 3, and here's the y equals x plus 2 here. So y equals x plus 2. This is y equals x. And what we're trying to do is we're trying to revolve this around the y-axis, right? So that we make a solid. The thing is that we've done this revolving around the x-axis and the y-axis with two sort of boundaries, right? With like an upper and a lower, or a far right or left and whatever the inside, outside and inside function. We've done that, but we've never done one like this where really there's three boundaries, right? So what we have to do is you have to break it up, and again, this is the method that I've taught you. So you have to break this up into three sections. So the first section is going to be this one right here that I'm going to outline in blue. Okay, so this section we can revolve. That one is just the disk method, right? We'll revolve that around and so on. So this is disk method. So this one, no problem. So this, we're going to call this region A, all right? And for A, we are going to do the following. So we're revolving it around the y-axis, and so that means that I have to change each of these functions into x equals. So what's this going to be? X equals what? Y minus 2. This one is going to be x equals y, right? And of course, this line here for later is going to be x equals 3. Of course, it already is x equals 3. So we'll keep that under hat. So for A, the volume of revolution is going to be this. The volume is pi times the integral. Now we're going to go, again, on the y-axis. You have to look at up, right? Because we want this dy, because we're going to revolve it around the y-axis. So it's going to go from 0 to 2. So from 0 to 2. And really, if we look at the far right function, that is this line, y equals x, or x equals y, right? And so pi r squared, pi, the radius here is simply x equals y. So it's going to be y squared. So that's how we're going to get, and that should ring a bell, right? You've done questions like this where we revolve just this part around, and we're going to get this little volume here.
How come that r is y?
How come the radius is y? Because we're not revolving around the x-axis, right? We're revolving around the y. So you have to have all of your functions isolated for x in terms of y. So it's got to be a function of y, because we're revolving it this way around the vertical y-axis, you know? Okay? So this one here, I'm going to spare you the by hand method here. So I'm just going to, actually, you guys can do this, right? We know how to do this on the graphing calculator. You just put this function in, and which I'll just pause for a second. Okay, so if we plug this in, remember that it doesn't do x equals y squared, so the variable has to be just this x button. So this is the same as graphing x squared. And we want to find the integral, or the area underneath that curve between 0 and 2. So second function, trace button is the calculate menu, and down here to 7 is integral. See that? So 7, lower limit is 0, enter. Upper limit is 2, enter. And it'll show you the area under the graph, and it'll give you this number, 2.67, so that's, what's that? 2 2/3, right? Pi, which is 8 over 3.
How do you know it's 2 or 2/3? It says 2.6666.
Yeah, okay, so if it says 2.6667, that's 2/3. 0.6 repeating is 2/3. So you could just, I'm okay with the decimal. Okay, because you're using the calculator. The reason why we would do this by hand, which would be pretty easy, you would get 8 over 3 pi, or 8 pi over 3. Okay? And so that one, yeah, I guess, so if we're just going to do decimal, then it's going to be 2.6666 times pi equals 8.378. Okay? So there is the volume for A. Got that? That's the first part. Okay, so now let's make some space here. Okay, so we'll remember that number. And what we need to do is we need to look at section B now. So I'm going to get rid of this. This is tricky. Section B, again, we just need two boundaries. So if we move up the scale, we can go from 2 to 3. Okay? We can do this section here now. And we can actually revolve that one around. Right? Revolve it around. Washer method here now. So for B, if we call this here B, then the volume for B is going to be, so pi r squared, right? So pi times the integral. We know we're going to go from 2 to 3. And this one is going to be the far right boundary. So what's that going to be here? That's going to be your x equals y line, right? So that's going to be y squared minus, what's the inside line? Y minus 2 squared. dy.
Y minus 2?
Yeah, because that's the line here. That's the equation of the line. See that? So it's the outside.
Oh, yeah.
It's the outside minus the inside, right? To get, all right. So that's your second part. And again, just to kind of speed this along, we could do this on the graphing calculator. You could also expand this, integrate, right? Do it, with 3 included, 3 plugged in, minus with 2 plugged in, and so on, the long way. But you could also just do it in your calculator. And what you should get, V of B, should be 6 pi. And you guys can check that on your calculator. And so for a decimal, if we're okay with decimals, 6 pi is just going to be 18.496. Okay? And on your calculator, you can just plug this right in, right here. Plug that in, graph it, find the integral, multiply that number by pi, you should get 18.496. So just take a moment to double check that in your calculator. All right, so on your graphing calculator, here you go. You get 6 right here. That's going to be your integral, and then times the pi gives you this number here. All right? And that's the second portion. Now, the third one for me was the trickiest, actually. So the third one, if you think about, let's do this in green now. So C, all right, we've got A here, we've got B here, now C. So C is going to be, well, the leftover piece is going to be this, right? So this one is just made from, just 2 functions as well. The outer function here is, what's the equation for this boundary here over here? X equals 3. No, it has to be isolated for x, yeah. So the y value is just y is 0 here, right? Like there's no y. So you could just use your far right boundary, which is x equals 3. So it's just going to be 3. And then your inner boundary here is, y equals -2. And so you're going to be basically rotating this around. Right? Rotating this around. So you're going to have this piece revolved around the axis here to make the third piece. And so if we do that, then that becomes, let's just do C here. That becomes pi, and our limits of integration are going to change as well. And that's going to be between 3 and what?
5.
Yeah. We got to go from 3 to 5. And so our far right boundary is going to be 3. squared minus the inner boundary is y minus 2 again, all squared. Okay, so that's again washer method again for C. And we'll plug that into our calculator here. So when we plug this in, okay, right there, the function, this graph that we see, remember, this does not have to look anything like what nothing. But what we're using is we're using the area under this graph to mimic the area that we see here highlighted in green, right? So we're doing second function. Well, it's the area. Yes, it's sort of the volume over pi. Really, it's sort of part of the volume, right? It's the r squared part. You know what I mean? So yeah, it's the area, but it's not just the two-dimensional area. So yeah. So here we go. Plug that in, and lower limit is then going to be what? 3, and then the upper limit is going to be 5, and then we get this 9.3 repeating. So we get pi times 9.3 repeating, and again that's going to be 9 1/3, right? Or 28 over 3. So it's going to be 28 over 3 pi, and as a decimal, because we're just concerned with decimals here, what's that going to be then? 28 over 3 times pi, oops, answer times pi, 29.321. 29.321. All right. Now, we've got the volume of the 3 pieces, right? And now we just add them together. So the volume total should be the volume of A plus the volume of B plus the volume of C. And the exact value for this question is 18 pi. Or if we're talking about approximate answer, you would come up with, when you add all those decimals, going to be 56.5486. 548, and we'll go to 7 there. And that's going to be units cubed. Hello.
Can you check my answer?
Can I check your answer?
Yes.
You think you got that one?
Yeah. Did I do something wrong?
So I'll just check in a minute.
Yeah.
Okay, so basically, here's sort of what this looks like, right? This volume revolved around that like there. Okay? Questions? All right, there's that question for you.